Okay, so we're going to look at the derivative of a trig function and its maximum and minimum. Okay, specifically local maximum and minimums here. But they've given us an interval of x that is going to be every real value between 0 and 2 pi. Okay, so we got to try to remember our sinusoidal function. And we want to find, they want us to determine the max and minimum values of the function f at x equals cos squared x. Okay, so in order to find max and min, Donna, do you mind closing the door? We have f at x is equal to our cos squared x. Okay. Now, from examples before, we know that this can also be rewritten as f at x is equal to cos x squared. So we're going to write it that way and derive it using our chain rule. Okay. So use our chain rule here. So derivative of f at x is equal to 2 times cos x. And then the derivative of the cos x is negative sine x. Okay. So we have this information, and we can go as far as say negative 2 equals cos x times sine x. Okay. So because we have negative 2 times cos x times sine x, okay, so with this information, we technically have our derivative function here. And because we're looking for max and min values, and we're between the interval of 0 and 2 pi, the idea here is we're looking for critical values. So we want to set this equal to 0. Okay. Now there is a way to go about this using your double angle formula to simplify, but instead of memorizing that, we can still solve with the information we have. This is essentially negative 2 times cos x times sine x is equal to 0. The negative 2 can be divided out on both sides, so we're left with 0 is equal to cos x times, sorry, that should be negative sine x in this case. Okay? So, what we're going to do is we're going to set each of them equal to 0. Cos x equals 0, and negative sine, oh, not negative, silly me, I took the negative out with the 2. I apologize. It is positive. Not that it made a difference. We could have worked with it that way also. Is equal to 0. Okay. So we're going to look for examples when cos x and sine x are equal to 0. So I'm going to try to recall my sinusoidal functions. And remember, we're between the intervals of 0 and 2 pi. So this is maybe our half pi, 3 pi over 2, and our 2 pi. Okay. For a sine, which we'll do in red, we go to a height of 1 and negative 1. Right? So we go up to a value of 1 for sine, back down at pi, negative 1 here, and there. So we have our sinusoidal function. This is at sine x. And our cos starts at 1 and follows the same wave-like pattern, just at different values. So that's our cos x. So values on each where we are 0, we're going to solve for. So what x values give us 0? Okay. So let's look here. Our x values that give us 0. For our sine, which is in red, the value of 0, pi, and 2 pi. So in those cases, 0, pi, and 2 pi are all values of x for us. Okay. And for cos, pi over 2 and 3 pi over 2. So when x is equal to pi over 2 and 3 pi over 2. These all give us values when x is equal to 0. So let's write it out in a long way in order. That would essentially be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So all I've done is combined all of my possible x values, the 3 here and the 2 here, to give us all 5. So these are 5 options where we can get a value of 0. Okay? The original question asked, determine the max and the minimums. So to find a maximum and minimum, we want to plug in, these are our values, we want to plug them into essentially our function here. Okay? So our function, the one I've written in blue, we're going to plug our x values in to find out what the y values would be at that point. Because remember, our original function isn't just cos, it's cos x squared. Yeah? We've taken our values and we're going to put into our formula of f at x will equal cos x, and I'm going to write it like this, squared. Okay? Our idea being here is we're going to plug all of our values in, each of these, to our cos wave, and then square each of them to figure out what our answers are. So when f at x is 0, our cos at 0 is a value of 1. Okay? So that means cos 0 squared is 1, and 1 squared is just a value of 1. Okay? F at pi over 2 gives us cos pi over 2 squared. And at pi over 2, our y value is 0. So 0 squared is still 0. So this value is 0 at this coordinate. With pi, we're at -1. Okay, so I'm just going to jump up and down here. So at pi, cos pi is technically -1, and -1 squared is just the value of 1. Okay. F at 3 pi over 2, jump back up and look. 3 pi over 2 with our cos wave is 0 again, so 0 squared will be 0 again. And f at 2 pi is equal to, well, let's look at where 2 pi is. 2 pi is a value of 1, so we're going to square the value of 1, which gives us an answer of 1. So these are all technically coordinates for our cos squared x. So in other words, if we were to graph this, which is a sinusoidal wave of this function, we'll use the same parameters, 0, pi 2, pi, 3 pi over 2, and 2 pi. Essentially what's happening here is when we're 0, we're at 1. When we're at pi over 2, we're at 0. At pi, we're at 1 again. At 3 pi over 2, we're at 0. And at 2 pi, we're at 1 again. So this is essentially creating a wave-like pattern, but not touching but not crossing our x-intercept. So what ends up happening is our max values, there's many of them, and they're all of the value of 1, being our max. And our minimum value here happens to be 0 in this case. So because we plugged in all those values, we're able to find the several minimums and the 3 maximums within that interval. But because the question only asks for the max and the min, the idea is that our maximum value is 1 and our minimum value is 0.